An egg falls safely onto a blanket. This egg falls on the floor, and the results are tragic. What was the difference? To understand why, we need to talk about the physics of landing. Impulse is equal to change in momentum. Impulse is the average force, but not just the force. It's the force multiplied by how much time the force is acting. So greater force means more impulse, and greater time means more impulse as well. Change momentum is equal to the object's mass, and supposing that mass stays the same the whole time, you just multiply it by the object's change in velocity, and you get its change in momentum. So really, impulse is what you do to an object, and change in momentum is how the object's motion changes, right? Different things, but they have the same value. Now let's take a look at this egg again that fell on the concrete. If you look at the clock in the background, it doesn't even change 1/100th of a second, meaning less than 1/100th of a second went by from when it was about 6 inches off the ground to where it had come to a complete stop. Its time of collision, if you're talking about the floor's force on the egg, is very, very small. Now, knowing that I dropped this egg from 1 meter, I'm able to estimate the final velocity before it hit the ground was a negative 4.5 meters per second, negative because it's going down. And its velocity after it landed on the ground, of course, was 0. Therefore, its change in velocity would just be its final minus initial, which would give us a positive 4.5 meters per second. Time of collision, you notice that the 100th place on the clock doesn't change, even though the egg has not even hit the ground on this side. So I can tell from this that the time of collision must be less than 0.5 of a second. And so I'll use 0.005, although the real value could be even less than that. The mass of the egg, before it cracked, it was weighed and found to be 0.054. And so we can use our equation. Impulse is on the left side, change momentum is on the right side, and we're going to plug in all the numbers that we know. Right? Only force is the only unknown. Everything else is known, so we can use some algebra skills to find this. Multiply the right side, then divide by the 0.005, and the left side cancels out. You get that the force is equal to all that right there, which we divide and get 48.5 newtons. Now remember, 48.5 newtons now is the average force. In reality, the force actually for a moment got even higher than that. We're not sure exactly how high because we didn't have a sensor there, but we could imagine it could get up, close to 100. So far too much force for an eggshell to handle. This is an example of a large force in a short time. But take a look at the other egg. The other egg came to a stop safely. You can see that the blanket both extended the time and the distance on which the egg came to a stop. Looking at the clock right before the egg hits the ground, hits the blanket, and looking at the clock right after the egg hits the blanket, you can see that only 0.05 seconds went by. Again, the egg was dropped from 1 meter, so it should have hit a max velocity of about 4.5 meters per second. So we have a change in velocity. We have a time, which is looks small, but still 10 times greater than the previous example. And we have the same mass of egg. Using our equation, we put in the numbers we know, multiply the right side, divide by 0.05, which cancels out. And when you put that in the calculator, you get a force of 4.85 newtons. So the average force was a much more gentle 4.85 newtons. And this was an example of a smaller force for a longer time. Both the blanket and the floor did the same thing. They brought an egg with the same mass and same velocity to a complete stop. However, the floor, because it's not soft, is not able to extend the time of collision, so it's not able to provide a safe landing to our egg. Whereas the towel, because it is soft and because it's able to move with the egg, is able to bring the egg to a stop in a longer amount of time, resulting in a smaller force and longer time. So this explains why some collisions are dangerous and some collisions are safer. Hopefully this helps, and we'll see you all in another video.